So in this video, we have some sample problems related dun sa ating previous discussion on the conformational stability and isomerisms in substituted ephanes and cyclohexanes. So for the instruction, draw the Sohor's and the Newman projections of the most stable conformations of the following compounds. So for number 1, we have 1,2-dichloropropane. Drawing muna natin yung skeletal structure niya. So ito-drawing natin si propane, okay? And the 2 chlorines, one in position 1, tapos position 2. So this is 1, 2, 3. Okay? Then, ito-drawing na natin yung Newman projection. Naka-specify naman dito, C1 at the back, C2 at the back, and C1 in front. So, yung in front na C1, that's the dot, okay? So, Newman projection. Tapos, ito-drawing natin yung tatlong substituent. So, yung tatlong substituent sa 1 ay yung Cl at yung dalawang implicit hydrogens. Okay? Tapos, yung C2 na nasa likod, okay, which is this, ang substituents niya ay yung methyl group, tsaka isang Cl, tsaka isang implicit hydrogen. So, H, Cl, okay, tsaka CH3. So, if we analyze this structure, tapos tinry natin siyang i-rotate, magkakaroon na niya ng gauge interaction. Kasi pansin nyo, kung i-rotate nyo yung nasa likod, magiging nandito na yung Cl. So, pin-rotate nyo siya doon, nandun na yung Cl, okay? Tapos yung CH3 nandito na, tapos nandito na yung H. So, CH3, and H. Okay? So, since H lang naman to, yan. So, may gauge interaction na between the chlorines. So, hindi yun masyadong stable. Okay? It's less stable than the original structure we drew. So, ibig sabihin, yung original structure na drawing natin, yun na yung most stable conformation. So, take note na yung malalaking groups like yung fluorine, they have to be as far away from each other as possible with respect to the dihedral para ma-consider natin siya na most stable conformer. So yung CH3, it's quite smaller than the Cl, okay, because of the size of the carbons and the hydrogens. Although magkakaroon pa rin naman tayo ng gauge interaction tulad ng gauge interaction dito, well, that's less, okay, parang less hindrance naman siya compared dito sa dalawang chlorine kasi yung CH3 ay kind of smaller than chlorine. Okay? So, let's erase this because this is the less stable structure. Tapos, erase na rin natin yung mga signs. This is the most stable structure for number 1. So, ito-drawing na rin natin yung Sohor's projection. So, kung Sohor's projection, nasa harap yung carbon number 1, we have Cl, H, and H. Tapos, yung nasa likod, okay, nandito yung dalawang hydrogen. Hindi pala dalawang hydrogen. Okay. So, nandito yung Cl, nandito yung hydrogen, at nandito yung CH3. Okay? So, the structures are basically the same, magkaiba lang ng projections. Okay? So, for the next number, we have 2-chloro-3-methylbutane. So, drawing ulit natin yung kanyang skeletal structure for convenience. Drawing natin yung butane 1, 2, 3, 4. Sa position 2, meron tayong chloro. And sa position 3, meron tayong methyl group. Okay? So, 1, 2, 3, 4. So, sa Newman projection, drawing natin siya. Okay? That's carbon number 2. Yun nandito. 2 in front. So, ang nasa carbon number 2 ay isang Cl, isang CH3. Ito yun, yung carbon number 1. Tsaka isang implicit hydrogen. Doon naman sa carbon number 3. Okay? Tatlo din yan. So, meron tayong dalawang methyl group. Okay? CH3, CH3, tsaka isang implicit hydrogen. So, is this the most stable conformation? So, check natin. Meron silang dalawang gauge interaction. Okay? Yung Cl-CH3 gauge interaction, tsaka yung CH3-CH3 gauge interaction. So, kapag ni-rotate natin yung likod, okay, we have this. Okay? Yan, meaning nandito na yung CH3. Ang rotation natin ay counterclockwise. Okay? So, nandito yung CH3, nandito na yung H. Okay? Tapos, nandito na yung isa pang CH3. So, nasa harap ay H, CH3, tsaka Cl. Okay? So, magkakaroon ng overlapping gauge interaction kapag nagkaroon ka ng ganitong conformation. Okay? So, this is less stable. So, pag ni-rotate ulit natin yan, okay, we have this. Rotate ulit natin siya counterclockwise, okay? So, we have H, okay, CH3, and then CH3. So, nandito pa din naman yung CH3, dito yung H, and Cl. So, yung gauge interaction, overlapping pa rin, although there is only one CH3Cl gauge interaction. Dito may dalawa. Okay? Tapos dito, dalawa yung CH3CH3 gauge interaction. Dito, isa lang yung CH3CH3, tsaka isa lang yung ClCH3 gauge interaction kasi separated sila by those hydrogens. So, ibig sabihin, this is the most stable structure. So, I'm going to erase the others. Okay. So, nakuha na natin yung most stable conformation ng number 2. Didelete ko lang din yung mga markings. Ayan. Yan na yung most stable conformer. So, idodrawing natin yung horse for projection niya. Yung front ay kaganyan. Okay. Tapos, yung back ay ganyan. Okay. So, sa front, we have Cl, H, and CH3. And then sa likod, meron tayong CH3, CH3, and then H. So, medyo diskarte din tayo dito kapag naghahanap more stable structure. We can count the number of gauge interactions. Okay? So, pag mas maraming gauge interactions, yung staggered na structure na yun is less stable. So, we move on to number 3, cis-1,3-dimethyl cyclohexane. Oh, this is a cyclohexane. So, ibig sabihin na pagdodrawing natin ng Newman ay dalawang bilog na. Okay? So, okay. So, i-practice nyo na lang din mag-drawing ng Newman projections in the future. Ganyan. Ganyan mag-drawing ng Newman projection ng cyclohexane. So, kapag sinabing 1 and 3, pwede natin gamitin to. Okay? So, cis na 1 and 3, pwede kasi siyang dalawang axial or dalawang equatorial. So, mas maganda na dalawang equatorial na lang para maiwasan natin yung 1,3 diaxial interactions. So, yung dalawang methyl group, lagay na lang natin CH3 dito, and then CH3. Okay, this is the most stable. So, the rest are hydrogens na lang. Okay. If you flip this cyclohexane, so if you flip natin, by rotating this, magkakaroon tayo ng ganito naman, tsura niya. Okay. Ganyan. Kasi flip natin to, tsaka ito, pinagpalit natin yan, dalawang yan. So, na-rotate. Okay, pag ganun. So, itong mga equatorial methyl groups na to, naging axial. Okay. So, kulang pa pala, meron pa tayong ganyan. Yan. So, this is the least stable kasi meron tayong 1,3 diaxial interactions na nag-occur kapag may ganyan. Okay. Pag ganito, walang interactions with the other hydrogens whatsoever. So, meron lang tayong gauge interaction, pero it's far less or far more stable than the 1,3 diaxial interactions brought about by this structure right here. So, buburahin ko na lang din ulit itong structure na to because this is the less stable one. Okay. Tapos, buburahin ko na rin yung markings. Ayan. So, this is the most stable structure for this particular cyclohexane. Dodrawing ko na rin yung inyang Sohor's projection. So, yung Sohor's projection nito, you just have to draw this line, okay? Tapos, ganyan. Okay? Can exaggerate the length. Yeah. So, 1, 3. Pili kayo ng 1 and 3 positions. So, I choose this. Okay? 1, 2, and then 3. So, ang axial niyan ay pataas. Okay? Ang axial niyan ay pataas. Pareho. So, therefore, ang equatorial niya ay pababa. Okay? Pag ganyan. So, this would be the CH3 in carbon number 1 and then the CH3 in carbon number 2. Or pwede nyong ilagay na ganyan na lang. Okay? So, burihin natin yung axial. So, ayan. So, ganyan yung structure ng most stable conformations ng cis-1,3-dimethyl cyclohexane. So, kapag cis-1,3, the most stable conformation is most probably the one with the substituents that are both in the equatorial position. So, next is number 4. We have 3-chloro-2-methyl-1-cyclohexanol. So, itry natin siyang isulat muna using the Newman projection. Okay. So, for this representation, nahanap tayo ng position 1, 2, and 3. Ayan. So, for the position 1, ito muna yung gagawin kong position 1, yung nasa likod. Okay. So, yung mga, or yung OH group ay nandito. Okay. For the position 2, ito yung position 2 natin. Okay, lalagay ko dito yung methyl. Okay. And this is supposedly the position 3. So, hindi siya masyadong magandang representation kasi this is not, or this does not exhibit or does not demonstrate which one is the axial or the equatorial. Okay, hindi natin magagamit yung Newman projection to properly illustrate this structure. Okay, so gagamitin na lang natin yung Sohor's projection. Okay, so for the Sohor's projection, I'll just draw the chair conformation of the cyclohexane. Yan. So yan yung chair niya in the Sohor's formation, and this will be carbon number 1. So since ito yung, or this will be carbon number 1, okay? So since yun yung axial position ng carbon number 1, ito yung equatorial niya, ilagay natin dito si OH. Okay? So this would be carbon number 2, since ito yung axial position niya, dito natin ilalagay yung CH3. And finally for carbon number 3, since ito yung axial ng carbon number 3, dito natin ilalagay yung Cl. Okay? So this is supposedly the most stable conformation kasi nasa equatorial lahat. Minimal ang kanilang interaction. Although may mapapansin tayong gauge interaction between OH and CH3, hindi na natin yun matatanggal dyan because of the adjacent positions of these carbons. Okay? Kahit anong flip ang gawin natin dyan, magkakaroon ka ng gauge interaction. So that is given, okay, sa structure. Hindi natin matatanggal yung gauge interaction just by changing the conformation. However, this is the more stable structure, okay? So, bakit? Kapag finlip mo kasi ito, magiging axial lahat ng iyong mga equatorial substituents. So, mangyayari, this will be carbon number 1, okay? So, kung yan yung carbon number 1, ito na yung magiging position ng OH. Kasi, equatorial siya dito na downward, magiging axial siya na downward doon. For carbon number 2, okay, ito na yung magiging position ng CH3. Okay, so equatorial siya dito na upward, magiging axial siya na upward doon. Next is for carbon number 3, dito, since this is equatorial downward, magiging axial siya na downward na Cl. Okay? So that is for the sample problems for the conformations of substituted ethanes and cyclohexane. So more problem sets tayo sa mga susunod na videos. Okay? So see you next video.